As the name implies, carboxylic acid, right? They act as acids. And so they have acidity. If you think about the acid-base reaction, you can easily identify the most acidic proton. It's the one that's attached to the oxygen. We can easily deprotonate that. And the reason that it's so acidic and able to deprotonate this so easily is because this conjugate base is stabilized through resonance, right? This negative charge is across two oxygens, which is a very electronegative element. And so this, the conjugate base is very stable, which makes the compound very acidic. In general, they have pKa's from about 4 to 5, depends on the exact carboxylic acid that you're talking about. And just for reference, alcohols have around 16. Really depends on the type of alcohol you have. But overall, you can see they are indeed a lot more acidic. Remember that a lower pKa is a more acidic compound. And like we've learned with alcohols and all the other different compounds, there's substituent effects. Right, we can add things to our carboxylic acids to either make them more or less acidic. So when we have a regular carboxylic acid, we can think about adding electronegative atoms, which will form an inductive effect, which will make the compound more acidic. So for example, this regular acetic acid usually has a pKa of 4.8. You add that chlorine, 2.9, add this OH, right? There's no resonance available here. So it's only the inductive effect from the electronegative oxygen. This is 3.8, right? This is all inductive effect. And of course, if you place more electronegative atoms, you'll get more acidic. If they're closer to the carboxylic acid, they'll make it more acidic rather than further away. Nothing really new here. And then, of course, we can extend this to benzoic acid derivatives. So, for example, if we have this guy right here, compare it with our regular just benzoic acid. And then this guy right here, right? If you take a look at the pKa's, here it's 4.5, here it's 4.2, and then here it's 3.4, right? So remember that this methoxy is an electron donating group, and electron donating groups make the compounds less acidic, right? This is the same thing that we learned with the phenols. Whereas over here, we have a nitro group, which is an electron withdrawing group, which makes it more acidic. Right, and these have to do with both inductive and resonance effects.